We now turn our attention to the x nullcline. We've already plotted the x nullcline in our axis above, and we'll notice that at these points, dx dt is equal to 0. That means there's no change in the x direction, and that there's only change in the y direction. So the slopes in the phase plane should be vertical. So what I'm going to do is I'm going to plot some vertical slopes on the x nullcline. So I'm going to make these vertical vectors. I'm going to put them all along the x nullcline. I'm not going to put any arrows in yet because I don't know whether they're pointing up or down yet. I'm also only going to plot them for x and y positive because x and y represent populations that are competing, and those populations are going to have to be greater than or equal to 0. So now I'm going to look at those specific nullclines and try to figure out whether those arrows should be pointing up or down. So looking at the x nullcline where x is equal to 0, I'm going to plug that into dy dt. dy dt in that case is y times 3 minus y minus 0. And I'll notice that that quantity is positive when y is between 0 and 3. That means these arrows, where y is between 0 and 3, will be pointing up because dy dt is positive. I'll then look to see where that derivative is negative, and I'll notice that that's when y is bigger than 3. And so when y is bigger than 3, I'll have my arrows pointing down. So that gives us the first x nullcline. The second x nullcline occurs when when y is equal to 2 minus x, and dy dt there is 3 minus y minus 2x. I'm going to approach this a little bit differently by just choosing a couple points on the x nullcline that are to the left and to the right of the equilibrium point. So I'm going to choose x equal to 1/2, and y is then 3/2. I'm going to plug that into dy dt. So dy dt is going to be 3/2 times 3 minus 3/2 minus 2 times 1/2. So that would equal 3/2 times 1/2, which is 3/4, which is positive. And so it turns out that if I choose any points that are to the left of the equilibrium 1, 1, all the slopes there are going to be positive. Now let's see what happens to the right of that equilibrium point. So this time I'm going to choose x equal to 3/2, which tells us that y is equal to 1/2. And then I'm going to plug that into our derivative of y. So I'm going to get 1/2 times 3 minus 1/2 minus 2 times 3/2. That's going to equal 1/2 times, and if I subtract 1/2 and then also subtract 3, then I'm going to get a negative 1/2. That's going to give me a negative 1/4, which is negative. So that's going to tell me that points to the right of that equilibrium point are going to point downward. And that gives us the directions for the x nullcline. Now what we want to do is we want to turn our attention to the y nullcline. Well, on the y nullcline, we're going to note that dy dt is equal to 0. So there's no change in the y direction, so there's only change in the x direction. So the slopes in the phase plane should be horizontal. And we want to use the same technique to determine whether those horizontal slopes are pointing to the left or the right. So first, I'll notice that along this green y nullcline, all of my slopes are going to be horizontal. And then along this green nullcline, all of my slopes are going to be horizontal. So now I want to do kind of the same thing that I did before. So first I'm going to choose the nullcline y equals 0. There, dx dt, let's see, dx dt in that case is equal to x times 2 minus x minus 0. I'll notice that that is positive when x is between 0 and 2. That says that my nullcline slopes are going to be pointing to the right. There's one more there, okay? I'll also note that that derivative is negative when x is bigger than 2, and so therefore slopes to the right of 2 are going to be pointing to the left. So now I just need to fill in the slopes that are along the other y nullcline. That's when y is equal to 3 minus 2 times x, in which case dx dt is going to be x times 2 minus x minus y. And again, I'm going to choose points that are to the left and to the right of the equilibrium point 1, 1. So we'll start with points that are to the left. So we're going to let x equal a half, in which case y is equal to 2. And then dx dt is going to be 1/2 times 2 minus a half minus 2. So that's equal to minus 1/4, which is negative. So I'll see that slopes in this region are pointing to the left. Now I want to choose points that are to the right of my equilibrium point 1, 1. So now I'm going to choose a point x equals 5/4. A little difficult to choose a point that's right there in this region. But x equals 5/4 should work. Then y is equal to 3 minus 5/2, which is equal to 1/2. In this case, dx dt is 5/4 times 2 minus 5/4 minus 1/2. So that looks like it's going to be 5/4 times 1/4. And the most important thing is that which is 5/16, is positive. So that means that this slope is going to be pointing to the right. And that completes the arrows for the y nullcline.